Hi, my name is Harshil Patel, and I head up the bioinformatics team at Seqera. So I'm going to be talking to you today about some of the problems that we're trying to solve at Seqera in order to address the challenges that are coming across bioinformatics within 2025 and beyond. So for those of you that don't know, Nextflow is and has become the standard workflow manager for writing and orchestrating pipelines within life sciences and beyond. And the idea behind Nextflow is that you write a pipeline, whether that's for RNA-seq analysis, chip-seq analysis, protein folding analysis, machine learning, and then you can execute and run that pipeline wherever you want, whether that's on AWS Batch, other batch providers, and also on conventional schedulers like Slurm and so on HPC, as well as Kubernetes. The idea behind that is you also use code repositories, which tend to be sort of software development best practices like GitHub and so on to version control your code and to collaborate and actually go and write your pipelines together as a team or as a community like is done in NF Core. You can use containers, which is where you get the reproducibility. So Docker, Singularity, they're awesome for actually getting the reproducibility that you need in order to be able to repeat the same analysis over and over again. And Nextflow takes care of all of these details for you. So you only really have to worry about running your pipeline and telling it very few details in terms of where you'd like to run it. It's grown quite massively over the years, as you can see on the plot on the left. And it's been used now by over 20,000 biometicians. It's got 2.5 monthly executions that we're tracking. So the adoption and the community around it has been super cool, and it's just growing from strength to strength. So in 2025, the bioinformatics landscape is and has changed quite significantly. I think a lot of you are probably aware that there's more and more data being generated, whether that's from conventional genomics type of experiments or proteomics experiments. Now we're seeing a lot more image analysis data that's coming out, as well as those that want to use and train machine learning models and so on. And that data is becoming more fragmented. The larger the organization gets, obviously that becomes a larger problem because you want people to be able to access data across these organizations. And typically these might be in different cloud regions or in places that you may not have native access to these things, and it becomes a problem for that. The complexity of the data is also growing, as we're seeing. So, as I said, image analysis, for example, you can't now download these images on your laptop and start doing analysis. You need to be able to utilize cloud resources and so on to be able to analyze that data. Compute has become more niche. We're seeing a lot more usage of GPUs, especially for AI, for life sciences applications, for proteins to see the acceleration that you wouldn't normally see with CPUs. And this has become quite important, especially when you want to scale your analysis. You want to do large cohort-based sort of analysis. You need to have the infrastructure at your fingertips to be able to go and run these analysis, especially if you are on a time pressure. Now also bioinformatics has penetrated further into the clinical landscape as well. And so we're seeing bioinformatics and Nextflow also being used further down in order to validate and run clinical trials, whether that's for GXP type of analysis or other validation, where you really need to use, say, for example, population genomics or other information to streamline and reproduce the data that you're doing in order to make it reliable. And that might involve version control as well as additional login and other things that you need to make sure that you have in order to satisfy the authorities. So just a brief background about Seqera. So we are the creators and essentially gatekeepers and owners of Nextflow. We also have a licensed product called Seqera Platform where Nextflow runs best. Nextflow was first sort of developed in 2013, so we've now 12 years in. Seqera was implemented in and started by Evan and Paolo, our founders, in 2018. So now that's sort of 7 years on. Time's flown really. The NF Core community, which was sort of an independent community that started out in between Nextflow and Seqera, was an idea led by Phil Yules at the company. And I've also been quite a big contributor to that over the years, where we have formed a community for best practice Nextflow pipelines, and it's become much more than that over the years now. And there's over 15,000 members within the Slack channel now. It's a really nice space to go and hang out and ask questions or even lurk if that's what you're into, to just get more information and be integrated as part of a community. There are over 100, I'm out of date now, probably 120, 130 pipelines now on NF Core that you can use off the shelf for RNA-seq analysis, ChIP-seq analysis, protein folding analysis, whatever you want. And even if you don't use them off the shelf, they're good for inspiration in terms of how you can get going with Nextflow and use these pipelines if you need to. So in terms of our customer base, we have a lot of small biotechs, mid-market customers, as well as larger enterprise customers, including almost two-thirds of the top 20 pharma. We've got over 130 customers. And as I mentioned before, we've also been used by a lot of government agencies, as well as academic institutions, in order to standardize the way that you're running Nextflow within your organizations through Seqera platform. So I just wanted to briefly give you an overview and touch on some of the challenges in bioinformatics today and how we're going about solving them at Seqera. When you need to do any sort of bioinformatics analysis, that typically involves a number of steps where you take the output of one step, and then that becomes then the input of the following step, and then you start chaining up a pipeline where you want to run a series of steps, either in parallel or you want to bring them together to look at all of your samples together, for example. And constructing those pipelines isn't trivial, especially when you consider that every single task in that execution, whether that's an alignment or running FastQC, has its own infrastructure requirements. Now, the way that we're solving that is obviously by using and running Nextflow. And Nextflow, you can have fine-grained control of how you write these pipelines, what the task requirements look like, what the infrastructure requirements look like. And so it really takes the pain out of you having to manage that all manually and scaling your pipelines, whether that's going from one sample to 1,000 samples, or the reverse. And so it really takes the pain out of doing that for you. And as I mentioned previously, there's a number of features there that allow you to exploit the reproducibility, scalability, portability that you get from using Nextflow. Reproducibility is super important in science. I think we know that, at a minimum, you need to repeat your experiment 3 times in order to get a reliable result. I think some statisticians will argue that it's probably a lot more than that. But if you can't get the same results from running your data analysis over and over again, then you kind of hit the same problems. And that's really why we built Wave. It allows you to run and build containers in a reliable way. It takes the pain out of building containers, especially for those that don't want to manually build Docker containers. And by leveraging the awesome resources that are available on Conda and Pipey, we can then go and build these containers on the fly for you, push them up to your private registries if that's where you want to host your containers, and augment them if needed to then go and execute custom binaries and so on that you need to go and run your analysis. And so it's a really nice, easy way to provision containers for your Nextflow pipelines, and it integrates seamlessly with Nextflow. If you can't access your data and know where your data is, then there's no point really doing any sort of analysis. And I think data is central to any bioinformatics analysis. Most scientists don't care about how the pipelines run. They just want access to their data. And they want to be able to run that data through a pipeline to get a result, then that they can then go and validate, depending on what the downstream steps look like. And so we've implemented Data Explorer in the platform, and that allows you to integrate with conventional cloud storage directly within your environment. And we're adding some additional features also to use and support sort of S3 compliant storage as well within Data Explorer. And what that means is essentially you don't have to leave the platform, or your users don't have to leave the platform to go and access, whether that's the inputs to your Nextflow pipeline, the outputs to your Nextflow pipeline, and any sort of other downstream data that you need in order to go and do your analysis and figure out your experiments, that they integrate all within Data Explorer, and they're made available, whether that's an S3 bucket or an Azure Blob Storage bucket or a GCP bucket. Compute resources. So as I mentioned earlier, now pipelines and data analysis are requiring more and more niche infrastructures and niche chips essentially to go and run your analysis. And the platform itself integrates natively with cloud resources, whether that's on Google, Amazon, AWS. Oftentimes now we also see that some of these resources are made available on HPC environments and GPU chips are installed directly there. But cloud providers tend to have most of the available resources there that you would need in terms of virtual machines to go and run your analysis. And providing you pay your cloud bills, which will absolutely come on time, then the platform allows you to provision those depending on the analysis you want. And so today you could be using spot instances because you want to do a quick, dirty, cheap analysis. Tomorrow you could be using on demand because you want that consistency and that turnaround time needs to be good. We also have some really good features within the platform now that can leverage spot and snapshotting via our Fusion file system. So you can actually leverage the cheap pricing as well as the reliability almost that you get with on demand, and tasks can pick up wherever they left off in the execution. In terms of understanding your results, so at the end of an Excel pipeline, you might want to know why and how your experiment was run and whether the QC looks good and or not. And so we are also the maintainers of multi-QC now. So Phil Yules, who was the main author of multi-QC, is now at Seqera. And multi-QC integrates with over 200 to 200 conventional bioinformatics tools to go and scrape any logging information that they provide to generate a comprehensive report that you can use to go and actually troubleshoot your results and figure out what's going on within your data. And that might mean that your experiment works swimmingly well, you go to your PI, you get the rest of the day off, or it means that you have to spend the weekend culturing more cells because you need to repeat that experiment. And so MultiQC is a great way of actually telling you how you need to do that and summarizing your results for you. And now also we've got some really cool AI integrations with MultiQC that give you a summary of your experiment at the top to indicate where you need to look. We've also developed a product called Seqera Studios. And so Nextflow typically requires much larger and diverse resources in order to go and run your analysis. Now, with Seqera Studios, this is a pretty much like an interactive notebook type of offering that we've got. It doesn't have to be a notebook. It can be anything that you want to run within a single container. So whether that's IGV or Jupyter or some other custom tool that you've got license for that you want to use for variant annotation, you can spin up an individual virtual machine in the cloud now to go and run interactive analysis. And so this may be that your Nextflow pipeline produces some differential output results. You now want to go and visualize those as a PCA or even with single cell where you want to go and look at a UMAP, for example. You can load these up via Data Explorer into Seqera Studios to go and start looking at your data directly within and using the cloud resources, for example, that you've already provisioned within your environment. And so this takes the pain out of you downloading that data, 30, 40 gig BAM files just to go and look at a variant, for example. This works directly on top of blob storage with our Fusion file system. So you don't have to move the data around. Everything is written back to blob storage. There's also snapshotting features available within this. And so what that means is, or even checkpointing features, that allow you to then go and checkpoint what you've done with your studio so you can recover it and have sort of a trace of how you've been using it over time. And this again ties into the strong emphasis that we have as a company for reproducibility. Nextflow is great for that. And now we're trying to use containers in the same way, but in a single virtual machine type of way. So you can run interactive analysis too and chain those pipelines together if you need between Nextflow and running something more hands-on via a custom piece of software. So I'll go through each of our products very quickly and in a bit more detail, just to show how we're doing this and for you to be able to visualize what we're doing on that front with pipelines, data, and interactive analysis. And so, in terms of Nextflow pipelines, you can run Nextflow within the platform. There's tons of information there that you get for your pipeline execution at the task level. You can then go and actually see how long each task took, the virtual machines that were provisioned for it, how much this individual task cost as well by using our resource labels offering as well. So you get an accurate idea of how much things cost. You can go and actually access Data Explorer via at the task level to go and look at the command files and download them directly here. So you don't have to go and find a random S3 path within AWS and the console to go and troubleshoot this. And so it makes it a lot easier within your organization to go and use Nextflow in the way that you need to. And there's lots of other cool features here. All of your parameters and configuration is also tracked here. And you get an idea of who's running what on a daily basis. So you can collaborate across your team to help them troubleshoot if needed. You can bring your own pipelines into the platform. So any Nextflow pipeline, whether that's on GitHub, GitLab, Bitbucket, and you can use containerization in the way that you need to, whether it's Docker and other sort of cloud-centric providers. They have their own like ECR, for example, and run those within the platform. So it's a really nice, easy way for you to centralize how you're running Nextflow within your organization. In terms of data, as I mentioned to you previously, Data Explorer, it allows you to go and mount any bucket directly within the platform as well, whether that's private or public. If you wanted to browse the 1,000 genomes data, it allows you to go and browse that there. Then you can potentially, just out of interest, spin up a studio, as I mentioned earlier, to go and actually look at variants directly from 1,000 genomes without needing to go and download or sync that data within your environment. So it makes it very easy to hook in blob storage directly within the platform, so you can go and investigate and use that within your own data analysis pipelines. And oftentimes, a lot of studies are comparing directly to public data, and there's some awesome resources available on the various cloud providers, especially on AWS. So with Studios, you can spin up interactive environments to go and run your data analysis. And so this is behind the scenes, it's just a single virtual machine. What's really nice about this also is that you are basically limited by the resources and virtual machines available in your cloud environment. And so if today you wanted a GPU environment because you wanted to use some sort of accelerated software, you could quite easily spin up a studio that is utilizing GPUs behind the scenes for you to then go and run some sort of niche analysis in the way that you want. You can also then hook in your data however you want. And so using the Fusion file system, this data is made available directly to you sitting on top of blob storage. So you don't need to worry about going to access that data in S3. It's almost like you're working on a laptop essentially to go and do your analysis, and anything that you edit or save will be saved again directly on top of S3. So in terms of compute, the platform makes it very easy for you to go and either bring your own compute in, whether that's your own cloud provider. We don't host any of your data. We do have a managed offering called Seqera Compute. If you don't want to have to worry about managing your own compute environment and AWS account and the whole DevOps functionality that goes behind that, you can use our Seqera Compute offering for that. However, a lot of organizations are also bringing data directly into the environment directly via interactive analysis. And so whether that's using AWS to plug in your credentials and your storage, you can use that directly within the platform and hook that in. And we have a feature called Batch Forge, which then goes and creates all of the compute environments and credentials and resources and appropriate permissions for you to then go and use this environment directly within the platform. And this way, you're running Nextflow in your environment on your compute and storage. Once you delete the compute environment in the platform, it will be deleted directly within your cloud environment as well. So it's very easy to go and do this. You can also specify custom resources if you wish to use them, whether that's GPUs or ARM or AMD instances. And the platform will provision those, providing you have access to those and quotas for those within your cloud account. Another option with our compute is the fact that we have also developed a file system called the Fusion file system. And what that allows you to do is essentially treat blob storage like a local file system. And so what you can do with Fusion is you essentially mount blob storage into the containers where Nextflow is running. And so typically that wasn't the case historically. And so Nextflow would have had to copy all of the data that you need to go and run individual tasks, whether that's a genome reference or a FASTQ file or a BAM file directly within within the task execution context, and that can be quite fragile because you're moving a lot of data around the cloud, and you tend to hit vendor specific API limits the larger your data gets. Whereas with Fusion, you're almost mounting that data within these containers now, like a local file system. And it allows you to essentially get rid of all of the stage in and stage out times when you're running Nextflow, to optimize the task execution. And in conjunction with NVMe instances, this can be even better where you want to speed up the I/O operations within the cloud using specific NVMe supported SSD disks. We also have a snapshotting feature as well, as I mentioned, which allows you to go and uh, have a snapshot of the task execution. So if your spot instances are reclaimed, you can pick up that task execution directly from where it left off without you having to go and rerun that particular task from scratch. And again, this is um, a very nice way of saving costs in the cloud and actually resuming your task execution, not only at the pipeline level, but at the task level. No talk would be 2025 without mention of AI. And so we've done a lot of work in this space recently, whether that's for looking at previous runs, developing code, helping with studios or compute, creating new data sets. And so we've got an offering called Seqera AI, which over time has become more and more crucial to going and writing, especially Nextflow pipelines. It's not like a typical LLM type model that you get with ChatGPT or otherwise. And it's been curated on very niche sources of Nextflow repositories, whether that's on NF Core or other niche sources, as well as all of the documentation that we have on Nextflow and Seqera. And so it's much more reliable as a resource for you to go and write your pipelines or even write tests. The things that are tedious when you're writing Nextflow pipelines, it really takes the pain out of doing that. There is right now you can use Seqera AI using Copilot directly within VS Code, and so we've added integrations via the Nextflow plugin for you to then go and write your pipeline in line with Seqera AI. So it allows you to go and um, bring AI to where all of the magic is essentially happening. And you can even, there's various different commands for writing tests and so on. And then you can, accept the changes as you would with something like Claude or otherwise. And it makes it much easier for you to then go and troubleshoot and debug. This has now also got direct integrations with the platform as well. So you can go and search for runs, you can troubleshoot runs and various other really cool things. Even creating GitHub pull requests, which is something that is relatively new, but will probably be coming out in the very near future. So hopefully I gave you an overview of what we're trying to solve at Seqera, and we're trying to really scale science in general, whether that's on the compute front and using all of these really cool resources. It's just the way that the bioinformatics landscape and tech landscape is going today, whether that's scaling your projects and trying to build out your teams and how you scale on those projects and collaborate on those particular projects to make it easier for you to then go and access data or run analysis, and also how you develop your code as an organization to make it easier using something like Seqera AI, as well as running that code development environment within a VS Code studio that we've got in the platform. So you don't need to go and worry about provisioning the resources. You can standardize all of these things within your organization using the platform. And thank you for listening to my talk. And for those of you that we met, thank you for coming to meet us at the booth. Thank you.